Hi, Algebra 1. In this lesson, you're going to be working with the vertex form of a function. So we've seen factored form, we've seen standard form, now we're looking at vertex form. One interesting thing about these sets of quadratics is that they are all actually equivalent. They're all showing the exact same function. For example, function f and function g are easier to see that they are the same because function g, if you use a distributive property, you would easily see that you get back to f. Now function h is the same thing as f. This is in what's called vertex form, and we see that term right there in your book. And down here in your book, we're showing why h is equivalent to f. So we start out with function h right here. I've color coded it to match. And they're just expanding it out. X plus 2 squared is x plus 2 times x plus 2. And they are multiplying this out using the distributive property over and over and over again. Same way that we've been doing, or you could do the diagram. And once they get to this point, they combine all of their like terms. They have 2x and 2x to be 4x. They end up with a plus 4 from this last distributive property, and then there's still this minus 4 from what we started with. So that just ends up being 0. And so we simplify to just x squared plus 4x, which is the exact same thing as f. Now we're going to look at set 2, which also has equivalent quadratics with it. And we are going to show that r and p are equivalent. So we're going to start with r, and we are going to expand it out and finish our multiplication and simplify to get function p. So up to this point, we've just expanded x minus 3 times x minus 3. We use our distributive property over and over again, or you could use a diagram to get this. Now I'm going to simplify from here. I see that I have like terms negative 3x and negative 3x. And so I'm going to just write out negative 1 times x squared minus 6x plus 9 plus 4. Now we have to do our multiplication that we have left before we can add on that 4 on the end. And so I have to use a distributive property here with the negative 1 with every single term inside the parentheses. So I end up with negative 1x plus 6x because I have a negative times a negative minus 9, and then I still have the plus 4. Now these are my last two like terms, negative 9 and plus 4. And so I end up with negative x squared plus 6x minus 5. And if we look back, that's exactly what we have as the function p up here. So we've shown that function r is the same as function p. Number 2 now is giving us the graphs of graph h and function r. And it's asking us, why do you think these expressions are said to be written in vertex form? So the key word here being the vertex. So let's take a look at the vertex. In function h, we see that the vertex is right down here. The coordinates are negative 2, comma, negative 4. So what we want to see is what do we notice in the coordinates versus what we see in the vertex form of the equation. Then in function r, we see the vertex right here. Those coordinates are going to be 3, comma, positive 4. And again, what do we notice is common between this vertex and the equation? Hopefully you start noticing that we see some of the same numbers, specifically negative 4 here, negative 4 there. Same with the y values over here. Positive 4 is in the equation, positive 4 in the y value of the coordinate. Then I also see a negative 2 here and a positive 2 there. They're similar, but they're opposite. And I see a positive 3 here and a negative 3 here. Again, similar, but opposite. And that's what we're going to be seeing in the vertex form. We actually see the coordinates of the vertex show up in the equation if we know how to use them. For this next activity in your book, there is going to be a Desmos activity to use. The link should pop up here in Edpuzzle, and it's also posted on Canvas. So you will go complete that Desmos activity and then make sure you come back here to finish up the Edpuzzle video. There's a few important things in your lesson summary. The first being the vocab term vertex form. And they give you an example of a function right here that is written in vertex form. And then they have the graph of that same function right there. So you can compare how do you see this coordinate point showing up in vertex form? And again, the y values we see show up in the equation right here on the end of it. That's what's being added to the equation, and it's the exact same as the y value here. The x value of the vertex we see right here in our equation, but it is the opposite. So we need to remember that to find the x coordinate of our vertex, we need to use the opposite. So if it's negative, like in this case, we need to use the positive value in the coordinate of the graph. The last thing I want you to make note of is this right here, the general form of an equation in vertex form. This is saying that we have y equals a number, sometimes it's 1, so we don't really see anything there, sometimes it's going to be a different number, times x plus or minus a number. They're showing it as minus because then just h ends up being the x value of the vertex, and we should label that here. This is the x value of the vertex, and then plus k, which ends up being the y value of the vertex.